Okay, good morning, everybody. The last section for this week, 6.3, it's called Investigating the Sine Function. So throughout the course, we've been doing functions. This is the next one in the series. This is brand new to everybody. Whether you're coming from 10 Academic or 10 Applied, you haven't seen this before. Okay, so we're going to take it slow. We're going to spend 2 days next week talking more about these functions. So today is just kind of the introduction. Okay, so first of all, the sine function has the equation f at x equals sine x. This is known as a sine function. So the sine function has a few key features, which we'll discuss in a little bit. It has an amplitude of 1 or equal to 1. It has a period of 360. So remember, the period from the last section is the time it takes for one cycle to complete. So one cycle completes in 360 degrees, and that should kind of resonate with something else that you've learned back in your math days. The axis, which I'll give you the definition a little bit, is equal to 0. The domain is x element of the real, just like any other function, and the range is y such that it's between -1 and +1. Okay, and the sine function has 5 key points, and this is how you're going to be able to graph it later on. It starts off at 0, 0. So if you push sine 0 equals on your calculator, you're going to get 0. If you do sine 90, you're going to get 1. Sine 180, 0. Sine 270 degrees, -1. And sine 360 goes back to 0. So this is what it looks like on the graph. 0, 0. 90 goes up to 1. Back down to 0 at 180. -1 at 270, and 360 back to 0. So these are the 5 key points of the sine function. This is important because next week we're going to be moving this thing around. Okay, so here's a couple definitions. Graphs that are periodic and have the same shape and characteristics as the sine function are called sinusoidal functions. So that's the name of the chapter. That's what we're looking at this chapter. So going back to the equation of the axis. So the equation of the axis we said was equal to 0. So if I'm using my pencil, the equation of axis lies right here, right on the x-axis, which has an equation of y equals 0. So if you go back up to here, we told you the axis is at y equals 0. So the axis is just the halfway point. It cuts it and makes it a symmetrical shape. And this sine function continues. So that's kind of the middle ground, the equation of the axis. So that's the horizontal line halfway between the maximum and the minimum, the peak and the trough, which we learned earlier in this unit. And the amplitude, we were told that the sine function has an amplitude of 1. The amplitude is the distance from the axis to the maximum or the minimum point. So the distance from here, this axis, to the top, right here, this is the amplitude. It could also be from the axis to the minimum. This is also the amplitude. Okay, so when it's asking you to identify the amplitude, it's from the axis to the maximum point or from the axis to the minimum point. You choose whichever one you want to do. Okay, so here's the example for today. We're going to be interpreting this graph here. Okay, so if we take a look at this graph, it gives you Sarah's height above the bottom of the pool. It's height in meters versus time in seconds. Okay, so when we do that, we are asked, the depth of the water can be represented by the graph below. Discuss and interpret the graph. So the first thing we're going to look at is the period. The time it takes from one cycle to start and finish. Okay, so if the cycle is starting here, the wave pool goes up, down all the way, and then it stops right there, or one cycle stops right there. And if we go down, we can see that that happens at 3 seconds. Okay, so the period, or the time it takes for one cycle, is 3 seconds. The next thing we're going to look at is the equation of the axis. Well, if the highest point is 2.4 and the lowest point is 1.6, we got to get the middle of that. Okay, so you can do it visually. You can see that it's at 2 meters, or you can do it graphically or algebraically. You can add the highest plus the lowest point divided by 2, get the average. The equation of the axis is at 2. Okay, and the last thing is the amplitude. So if the equation of the axis is at 2, the distance from 2 to 2.4, that's the amplitude right there. is 0.4 meters. Same thing here. If you go from 2 meters down to 1.6, the distance is 0.4 meters. So that would be your amplitude. Okay, so that's explained here in the textbook on page 338. And the questions for tonight's homework, you're going to go to page 339 and you're going to do number 1 to 4. Okay, that's it for this week. 2 sections next week, doing some transformations with the sine function, and we'll get into it. Okay, so have a good weekend, everybody. Stay safe, and we'll talk soon.